So today we are going to start with our new next topic, which is regression modeling. Let's start. Regression modeling. It is a statistical and machine learning technique used to analyze and predict the relationship between a dependent variable, which is the outcome, and one or more independent variables, which are predictors. The primary goal is to estimate or predict the dependent variable's value based on the independent variables, making regression a critical tool for forecasting, decision making, and understanding causal relationships. So it is extensively applied in fields such as economics, finance, healthcare, and engineering. Types of regression: linear regression. So it models relationship between variables as a straight line. Then we have variance here as simple linear regression and multiple linear regression. Single linear regression it involves one independent variable, and multiple linear regression it involves and includes multiple predictors to explain dependent variable. So we can predict continuous outcomes like house prices and sales to linear regression. Then we have polynomial regression. So it is that it extends linear regression by fitting a polynomial equation to capture nonlinear relationships. And it is used for modeling curves and data where a straight line is insufficient. Then we have logistic regression. It's a classification algorithm that predicts binary outcomes, as for example yes or no, success or failure, by modeling probability using a logistic function. And then binary classification can be used. Then steps in regression modeling. First is data collection. So it gathers sufficient relevant data, then data clean preparation. It will handle all the missing values, outliers, and transform data if needed. Then feature selection, it will identify independent variables which are most relevant to the target. Then model selection, it will choose the appropriate regression type based on data and objective. Then model training, fit the data to the training data, fit the model to the training data using optimization technique. Then model evaluation, it will assess the model's performance using metrics such as R squared, which is proportion of variance explained by model, mean squared error MSE, average squared difference between predicted and actual values, and real mean squared error RMSE, which is the square root of MSE for interpretability. Then we have assumption validation with ensure assumptions like linearity, homoscedasticity, and independence are met. The advanced regression technique. First is rich regression, which adds a penalty to the model to address multi-group collinearity, which is correlated predictors. It prevents overfitting by shrinking coefficients. Then we have lesser regression, which is similar to rich, but enforces sparsity, effectively performing feature selection by reducing some coefficients to zero. Then we have machine learning based model, which incorporates algorithms like decision trees, random forest, neural networks, and for handling complex relationships and datasets. Application preparation, it is forecasting in stock prices, sales trend patterns. Healthcare, estimating patient outcomes based on clinical data. In economics, as modeling GDP growth or market trends. And in engineering, predicting system failures or material properties. Then by combining robust data preparation, appropriate model selection, and advanced techniques, regression modeling provides a powerful insight in prediction, making it a cornerstone of statistical analysis and predictive analytics. So demonstrate estimation model evaluation. So to estimate model evaluation, it involves assessing the performance of regression models, typically using metrics that capture difference between predicted and actual values. So evaluation metrics are MEE, MSE, RMSE, and R squared, which I have already discussed earlier in the upper, but we will discuss more once more. Mean absolute error, which is absolute difference between predicted and actual values, which is average absolute difference. Mean squared error, average squared difference between predicted and actual values. Root mean squared error, which is square root of MSE and C minus original data. R squared is proportion of variance in dependent variable that is predictable from the independent variables. Then we will import all the necessary libraries such as NP, PD, P will plot as PLD, train test, linear regression, and absolute error, mean squared error, R2 score. Okay, then we will so uh, now we will write the sample data set. Step one is that we will convert the data frame into PD.data frame. Okay, then we will split the data into features X and target Y. Then we will split the data into training and testing sets. Then we'll fit the linear regression model. We will try to predict your test data, then evaluate that model using key metrics. Then we will display results. And last is visualize actual versus predicted data. Then we will display it. Okay. Second is demonstrate stepwise regression. So stepwise regression is a method of selecting important predictors by adding or removing variables used on the statistical significance. So it automates feature selection to improve model interpretability and performance. It's a variable selection technique used in regression modeling to identify the most significant predictors. It involves adding and removing variables and based on criteria such as p-values, AKIC information criterion AIC or Bayesian information criterion BIC. And while scikit-learn does not provide a direct implementation of stepwise regression, it can demonstrate effectively using the stats model library. So example here as we will first import the libraries, then we will write the sample data set, then we will convert the data into data frame, then we will spread the features into data set into features and target X and Y. Then we will define the stepwise selection function, and then at last we will display it, perform stepwise selection, then fit the final model, and then display the final model summary. So the key steps are that function feature selection. So it starts with no predictors and iteratively adds the most statistically significant feature based on p-value, and stops when no remaining features meet a significance threshold. Model fitting, it fits a regression model using only selected features. Then model summary provides a detailed analysis of coefficients, p-values, and model fit statistics. So this was all for today, and thank you so much for watching and being so patient. Thank you and listening.